Okay. So I know most of you guys finished that in class. Okay. Y'all okay with that? The last two, you might star those, highlight those, whatever. I recall those being questions on the exam. They were multiple choice questions. So make sure you understand how to do those. I don't know if it's going to be this year or not, but I do recall that being a question a couple years ago. The translation stuff. I guess that would be, I don't remember now. I don't look at tests before you guys do. Like when you guys see the test is when I see the test. Because I don't, it's what do you call it? I try not to, but I do. If I see the test, then I'll emphasize that more in class. And I don't want to emphasize more of it. I want to emphasize all of it, if that kind of makes sense. So if I don't see it on the test, then I'll say, you don't need to know that, which it's not true because you do. Because I don't know what's on the AP test or not. Y'all good? Everybody okay? All right, so get that 12 done in Delta. Some of you guys still need to do 7 in Delta. And I'll get those grades updated. Everything else should be updated. Some of you guys have sent some stuff in later, so I haven't updated that yet. A lot of times what I'll do is when I grade it, when I decide to sit down and look at you guys' homework, right? If I tell you didn't turn it in, I'll say NTI. If you guys haven't, NTI, not turned in, just so you guys, that's mostly for you guys to know. I mean, I know that you didn't turn it in, but it's a reminder to you that you didn't turn it in. And most of the time that's it. Oh, I forgot to turn it in. And most of the time that's the issue, right? And I understand that. But that's why I do that. That's why I just return it with the NTI. And then, but I typically don't look at it again until test day. Okay, so I get notifications that you turned it in and that kind of stuff, but a lot of times I just don't look at it again until test day because that's when it's due again officially. If I don't look at it, like 12 was due this morning, if I don't look at it in time by you to turn it in, typically you still get the full points. I don't look at it as you turned it in late. However, if I grade it today, after I've graded it, I consider it late for sure, if that kind of makes sense. Anyway, just keep track of those type of things. If those 1 or 2 points end up being a big deal at the end of the year, and they might be, right? Just let me know. I don't want homework to hurt you, but I think it's important for you guys to get it done by the time you get to class. Because if you let it build and let it build and let it build and let it build, you're going to be behind. Okay. 213. 213 is heavy. So I'm splitting this up over 2 sections. And so this will be section 1 and section 2 when you guys get back from Turkey Week. So I'll call it 213A and a 213B. Okay. I do think that one of the free response questions comes from 213. So not A. It's a combination of all of it. So a lot of this stuff you guys have done previously, I want to make sure that you have, because again, it's going to be added to what you guys did in Algebra 2. In this unit, we have worked with exponential functions. So most of the 1.2.1 through 2.6 was exponential. Now we're kind of dealing with the logarithmics, which is the inverses of that. While utilizing important properties of each when simplifying expressions and finding equivalent representations. That's kind of the big deal about pre-cal, and I think that's what's different than Algebra 2. Now we need to use those same properties to solve equations and inequalities. And I know the inequalities is what's going to be new. That's what we'll do on Monday when we get back, the inequalities. Because I don't think you guys have ever solved inequalities. You've solved equations a lot. Involving exponential and logarithmic functions. Below are the important properties we have learned related to exponential and logarithmics. We need to be proficient with these properties so that you can use them to solve equations and inequalities, solving exponentials and logarithmic functions. These are the properties that we have gone over this chapter. You went over them last year. You guys have got to just know these and just be able to look at it and say, this is what you have to do. Hopefully you don't have to look back at this to say, this is what I need to do. Hopefully you know it. You know that if you have a b to the m and a b to the n, you can add those exponents only if they're the same bases. If they're not the same bases, you can't add them. If it's a power to a power, you can multiply them. If it's a negative exponent, you can put it underneath 1. If it's negative on the bottom, you can put it on top. So negatives get flipped. Logarithmics, right? Multiplication gets changed to addition, just like that. That's why the division gets turned to subtraction, and the power to power gets moved to multiplication. So the n just gets moved out front. Okay? And then, of course, I think the biggest ones are converting between exponential and logarithmics, doing the little loop, right? Log base b to the c is equal to a. You need to be able to float those back and forth just without, again, without thinking. It should just be almost automatic. Okay, so all those things we're going to be using in today's lesson. All right, so we're going to be solving equations. And some of you knuckleheads decide to use this to solve equations like on the last test when we haven't solved them before, and I don't know why you did because you had a calculator. If you have a calculator, I wouldn't do any of this stuff. I would solve with your calculator, like find out where they touch. If an equation or inequality involves a single logarithm, it means there's only a log on the left or a log on the right. So you don't see two logs. A single logarithmic expression. Or we can solve it by converting between exponential and logarithmic. So you're going to isolate the exponential or the log expression to one side. So whatever you got to do, you got to isolate that logarithm to one side. So you need a log on one side, either the right side or the left side. Blank the equation to the alternate form. Change or flip or rewrite. I don't know what you want right there. How about rewrite? Rewrite the equation to the alternate form. In other words, you're going to turn exponentials to logs, or you're going to turn logs to exponentials. Most of the time, you're going to turn logs into exponentials because that just makes more sense to you. And then solve for the variable. If necessary, sometimes it's going to be solved already. So sometimes you don't have to do anything. It's already solved. Simplify, round answers directed. Some of you knuckleheads still don't understand that you got to round to 3 decimal places. Still don't. Took off a lot of points for that, for not rounding to 3 decimal places. All right, here we go. Example, solve. That's 4 to the x minus 2 equals 7. Hopefully, the first thing we're going to do, we want to solve this for x. So the first thing I'm going to do is move that 2 to the other side. If I'm going to move that 2 to the other side, that's going to be 4 to the x equals 9. If you can't do that, show plus 2, right? Plus 2, plus 2. Now, I got to get x by itself, and I have no idea how to get that x by itself other than it's now written, what, exponentially? So let's just rewrite it logarithmically. Rewrite it logarithmically. Why? I don't know, but I can't take the square root of it. I mean, there's nothing, I don't know. I'm stuck. So when you get stuck, just rewrite it and see what happens. And this ends up being what? Log base 4 of 9 equals x. Voila, I'm done. That's what x is. X is log base 4 of 9. It says leave your answers in exact form. So my guess is this is non-calculator, and I don't know what that answer is, and so that's the exact form. And yes, you can rewrite that different ways. You can write that, what, as log of 9 over log of 4. There's different, I just leave it like that. Just leave it. The answer is definitely 1 point something. Because 4 to the 1 is 4, and 4 to the 2 is 16. And that's 9. So it's between 1 and 2. If just those kind of things help you think mathematically. All right, second one, B, 2 to the x plus 3 plus 5 equals 26. Hopefully the first thing we want to do is move that 5 over. Why? I don't know. I got to get x by itself, and I don't like that plus 5, so I got 2 to the x plus 3 equals, I'm going to subtract it, now it's 21. Now I'm stuck again. And this, you just got to get good at these by just practicing. Practice, practice, practice. But when you get stuck, my recommendation is to rewrite it. Rewrite it. Currently, it's an exponential form. Let's rewrite it logarithmically. So if I'm going to rewrite it logarithmically, this is log with the base of 2 of 21 equals x plus 3. And I don't want x plus 3. I want x. And so from here, there's one of two things you can do. I personally like -3 plus log 2 21 equals x. Some students will do log base 2 21 minus 3. Either one of those is okay. Just make sure you don't make that 21 minus 3 is 18, 19, 20. Don't make it log base 3 of 18. Y'all follow what I'm saying, right? When I move that 3 over here, you do not subtract 21 from 3. You just don't. Because there's no way the log base 2 of 18 is the same as the log base of 21 minus 3. Those are two completely different numbers. And leave it like that. Go ahead and leave it like that. Yeah, go ahead and leave it like that. If it was multiple choice, you may not see one of those answers. They may rewrite this as something really crazy like log base 2 of 8. Except that's not -3, so it'd be log base 2 of 1/8. All right, over here. -7 equals 3 minus 4e to the x. First thing I'm gonna do is move that 3 over there. So if I move that 3 over there, that's now -10 is equal to -4e to the x. Now I need to go ahead and divide that by -4. I'm trying to get it or x by itself. So there's no reason why I can't divide that by -4. And -10 over -4 turns into a positive 5 over 2. Go ahead and reduce that. Positive 5 over 2 is equal to e to the x. And I don't want e to the x, I want x. So let's just rewrite it. Except this time I'm not going to rewrite it logarithmically. I'm going to rewrite it natural logarithmically. Because of the e, you can log base e of 5/2, but log base e is the natural log of 5/2 equals x. Solve if needed, and it's already solved. You guys did this last year, yes? Solve for x's on logarithmics, okay? So some of these will be easy, some of these will be difficult, but when you get stuck, rewrite it. That's just my best recommendation. Rewrite it. I'm stuck. I don't know what to do. Rewrite it. Okay? All right. Example number 2. Notice example number 1 did not have any logs. They were all exponential, so I rewrote them logarithmically. Now I see logs. So my guess is I'm going to end up rewriting these exponentially. It only has one logarithmic, but I don't want to do anything until I get rid of that 4 and divide it by 2. And so let's go ahead and do that. Log base 3, x plus 3. 10 minus 4 is 6. 6 divided by 2 is 3. Yes, you can do that all as one step. You guys are in pre-cal now. If you're going to mess up, don't do it all as one step. But we as teachers now know that you can go from here to here without showing anything. Or at least I can. You don't have to show that I subtract 4 and divide by 2. You don't have to show that. If you're going to mess up, show it. Now I'm stuck again. So when we get stuck, rewrite it. Loopy. Right? 3 to 3. If you want to go ahead and say that's 27, that's okay. Is equal to x plus 3. Now it's really easy because 3 to the 3 is 27, but you got to subtract 3 more, and so I end up with 24. I don't think you can get by with any less work than that. Y'all follow? Y'all understand about showing work and stuff? I mean, I don't think you can get by with any less work than that on this problem. I just don't. You can turn that to 27, but even then, you still gotta. It's got to be written like that. Any less work than that, you're probably not going to get full marks. Y'all follow what I say on that, okay? And if you got more work than that, it's okay, but I don't think you can get by with any less work than that. Letter B, subtract the 2 first. So let's subtract the 2 first, and that's all I need to do. Log base 5, 2x minus 1, that's in parentheses, 2. Again, that's important to have that in parentheses because y'all see the difference between, well, I don't guess it's a difference, but y'all see that if that wasn't in parentheses, then I would add the 1 first, right? I would add the 1 first, then, well, I would put the 1 and the 2 together, I guess. Okay, anyway, rewrite it exponentially now. 5 squared equals 2x minus 1. 5 squared is 25. 25 plus 1 is 26. 26 divided by 2 is 13. And if that's not enough steps, show more steps. I don't want you missing it because of you don't know, you mess up on a 2-step equation. Don't miss it because of a 2-step equation. Yes? What minus 1 where? 2x minus 1. Where? What? Squared 5 is 25. Yes? It's okay. I've messed up before. Last year. That was last year I messed up. I hadn't messed up this year yet. Right? Everybody okay? Letter C. First step. Multiply both sides by 5. Multiply both sides by 5. ln 2 minus x equals 5. I'm stuck. Rewrite it. You can't, I mean, there's nothing wrong with rewriting it. Sometimes it doesn't work, but most time it will. Remember that this is base e. So e to the 5th is equal to 2 minus x. Yes? I didn't divide both sides by 5. I multiplied both sides by 5. It's okay. If you have to, show it. Right? If you have to, show it. Times 5 times 5. If you have to, show it. I'll do something probably a little bit different than others. I wouldn't move the 2 to the other because then you have a negative x. So I'm going to move the x over and move the e to the 5th over. But either way, I don't care. You can't have a negative x. If you want to move the 2 over, you got to switch all the signs. But I think it's easier to move the x over and move the e to the 5th over. So if I move the x over and move the e to the 5th over, it's going to look like that. This is, again, guys, those are not the only answers, right? You could have negative e to the 5th plus 2. I just don't like starting off with a negative if I don't have to. But understand there's other answers. There's not another answer for B. I guess you could have x equals 13 instead of 13 equals x, but same thing with this one. I guess you could have 24 equals x or x equals 24, but there's no other ways to write those. All right, very good. Now then, here's where it's going to change this up a little bit. When working with more than one logarithm, we can use our log properties to simplify expressions before solving. For equations and inequalities involving multiple logarithms, we generally simplify to one of those two forms. Log ax equals b, or log ax equals log ay. One of those two is typically what it simplifies to. He does this completely different than I ever did it. But if we simplify to form 1, we'll just rewrite it exponentially. If we simplify to form 2, we're going to finish by basically saying x equals y and solving it that way. All of this will make sense, hopefully. Important note about number 1. Why are you not going up? Oh, because I'm on the eraser. Important note about number 1. In either case, we need to check for extraneous solutions. Okay, so that's one thing that we forget to do a lot of times in log is we're supposed to check for extraneous solutions. And what does it mean by that? Guys, you cannot take the log of a negative. You cannot take the log of a negative. It's impossible. So I should check every time I see log, you should check to make sure you're not taking the log of a negative. When I put 24 up here, I got 24 plus 3, which is 27. I'm okay. That's all I really need to check. I don't need to check to see that it works. I'm just checking to make sure I'm not taking the log of a negative. It works if I'm not taking the log of a negative. 13 times 2 is 26, minus 1 is 25. I'm okay. That was hard to check. 2 minus e becomes a minus, becomes a 2 plus the e. So I got all pluses. I'm not taking the log of a negative. So, and then important note number 2, and this one's important because we see this a lot as teachers. Log x plus log y equals log z. So you got log x plus log y equals log z. For some strange reason, students think I can just drop all the logs. You can't. That's very, very, very bad math. It's just like the square root of something plus the square root of something equals the square. You can't just drop the square roots. Those pluses and minuses mess things up. It does not imply that x plus y equals z. We must use the log properties to simplify first. You cannot cancel out logs. So example number 3, you cannot just drop these logs and say 3 plus 4 plus x is equal. You can't do that, okay? We've got to simplify that. So I have a log, and I have a log. Over on the left-hand side, I have 2 logs. I would like to combine that using what we did yesterday's homework, okay? So this is the log. Instead of 3 plus x plus 3 or 4, this is going to be 3 times x plus 4. And over on the right-hand side, I'm not going to do anything. Some of you will be able to distribute that. That's okay too. You can make it 3x plus 12. You're getting ready to have to anyway. Okay. Pet peeve of mine is students just cross the logs out. Don't cross the logs out. You're not crossing the logs out. You're not. You're just mentally saying, this is the log of something, and this is the log of something. And so if this is the log of something and that's the log of something, those somethings have to be equal. They have to be. So I'm going to just drop down and say 3x plus 12 equals 5x minus 2. But don't cross the logs out. Yep.
Could you just move it over to be like log 3x plus 4 minus log 5x minus 2, combine that in one log?
I can combine all 3 of them into one if I wanted to. Yes. Y'all hear what he's saying? I could move this log over and subtract it, and this would be multiplication. Then you have division, but then you're going to have to end up multiplying to get rid of the fraction, and it's going to go back on the other side anyway. But there are more than one way to. That's what kind of makes these hard, guys. Is there's not one way to solve these. There are several things. As long as you're not doing anything wrong mathematically, it's okay. You're going with it. Well, I did this. Okay, I did this. You got to end up at the same thing, no matter how you do it. Now we're just down to a 2-step equation. Put that 3x over here, that's 2x. Put that 2 over here, that's 14. X equals 7. Check to make sure you're not taking the log of a negative. 7 plus 4, I'm good. 5 is 35 minus 2, I'm good. Always check. You know, you got when you first started doing algebra, they always said check your answers, and they probably even made you write down like plug in X and had on the right hand side and made sure it works. They always told you to check it, and we get out of the habit of checking it, but you got to check it on these because you can get extraneous solutions. Y'all remember what extraneous is, right? It looks like it works. You didn't do anything wrong mathematically. It just doesn't work. It just doesn't work when you plug it in. ln x plus 1 over 3x minus 5 equals ln 7. Bless. Good? Ah, boy. ln, so if I'm taking the natural log of two things, those two things have got to be equal. So we're kind of just dropping the ln's, but don't mark them out. Don't mark them out. X plus 1, 3x minus 5, 7. Multiply both sides by 3x minus 5. That becomes the distributive property. Don't just multiply it by the 7. You got to multiply the whole thing by the 7. That's 21x minus 35 equals x plus 1. Put 1x over there, and that's 20. Put 35 over there, that's 36. 36 over 20. Four goes in 36 9 times, 4 goes in 25 times. Make it 9/5. Question? Okay. Yucky. Log base 3. X plus 2. I heard y'all turn the page. Y'all turn the pages. Yeah. So we gave y'all more room than this. Yeah. That makes sense. X minus 3. You have to combine first. You can't just drop the logs. Please be careful of that. I say that because somebody will try to do it. You can't. Now you can go ahead and FOIL this thing out. X squared minus x minus 6 equals 14. This is when we start getting a little bit more difficult. You can't move the 6 over there because it's quadratic. You have to set it equal to 0 and use the 0 product property. So x squared minus x minus 20. Yep.
How do you extract the log 3 when you divide?
Where what?
If it's a log, wouldn't you divide?
Log where what? Divide by?
It's log base 3 of x squared minus x minus 6. Log base 3 14. Subtract that log base 3 14 and divide that.
You can, but then you're going to have you want to subtract the log 314 to the other side?
Yeah, because when you the log doesn't go away, so when you subtract the log from that side, then on the other side equals 0. Divide it.
I mean, I'm taking the log of that whole thing. I don't want to do that because then you can't see it. Ah, cuss. Forgot what it was. And they're both base 3, but it really doesn't matter. Okay, now you want me to move that log to the other side? Yeah? Now you want to divide it? Don't write this stuff down. Now what you got to do? Rewrite it logarithmically, or rewrite it exponentially. 10 to the 0, which is 1, equals that. Multiply both sides by 14, and that's where I'm at. Okay? Y'all good with all? Y'all kind of follow what all we've done? It's not wrong what he was telling me. Not wrong. You can move that over here, make it a division problem. We're stuck. We got to rewrite it exponentially. Okay? I think it's a little bit shorter to do it this way, but it works the same. It's not wrong as long as you don't do something wrong mathematically. This factors x minus 5, x plus 4. We're going to have to get that factoring comes back into play. You'll guaranteed you want to factor something. So x equals 5 or negative 4. It can't be negative 4. I can tell immediately because if I plug in negative 4, I got negative 4 plus 2, which is negative 2, and you can't take the log of a negative. You can't take the log of a negative. And what I would like to see, guys, is that. I would like to see 5 and negative 4 with an x to the negative 4. Or negative 4 doesn't work, or extraneous. But don't erase negative 4. Because if you erase negative 4, it doesn't look like you meant to even say that negative 4 is a possible answer. Y'all follow what I'm saying on that? Just put a little x to it, or put extraneous, or doesn't work, or false, or okay. Letter D, natural log, x over 3 equals 2. Stuck, guys, you know what I'm doing? Stuck, rewrite it exponentially. Yuck. This one's really gross. E squared, x over 3, multiply both sides by 3. X equals 3e squared. Good enough? Questions? Solve. Check for extraneous. Yuck. Log 4x over 8. Huh? Equals log 4x plus 7. Now you got log of something, log of something. You can drop the logs or you can say the somethings. So you got x over 8. Multiply both sides by 8. Hopefully you guys have more room than I do. Subtract 8, negative 8, negative 7, negative 7, 56. I got negative 8 as my answer. You guys will probably need more work or more room than that. However, what? Don't work. I plug in -8 right there, and I got a negative already. So no solution. You should put that. If it doesn't work, if that doesn't work, then nothing works because there's no other answer I have. It's impossible for me to take the log of 4 or something and subtract 3 log of something and get the log of x plus, there's nothing that x makes that thing work. If I graph this, that's how you can always check your answers, right? Use your calculators. Graph this and see where they touch. And those won't touch. They won't touch. Uh-oh. Let's turn colors. Some knucklehead's going to make that log of x over 2. You can't, because it's not the log of x minus the log of 2. Okay? So this is really tricky. I've got to make this log of x minus log of x minus 7. And then I got to put the 2 on the other side. I got to put the logs on one side. Got to put the logs on one side. Now I can make this log of x over x minus 7. I meant to tell you guys, I got a really bad habit. I didn't do it. I have a bad habit of, like, these 4s is starting to drop the 4s. Don't do that. I'll do it. Just out of a bad habit. Don't do it. Don't drop the other bases. It doesn't look like I've done it. No, these are all 3s. But I got a bad habit of dropping those. Okay. I'm stuck. I can't multiply both sides by x minus 7 because it's a log. So I got to rewrite it exponentially. So good thing I didn't drop this one. So 10 squared x over x minus 7. Yuck, sorry. Multiply both sides by x minus 7. So I have 100x minus 700 equals x. Yucky yuck. 700 over 99. I'm pretty sure that doesn't reduce. And 700 over 99 is bigger than 7, isn't it? Yes, because 700 over 100 is 7. So I'm safe. I'm not taking a log of a negative. Okay, so we amp it up a little bit right here. Here's f of x. Here's g of x. So look at what they say. Find all the values of x where f and g intersect. So that's just a different way of them writing, if f and g intersect, then the natural log of x plus 15 minus the natural log of x has to be equal to the natural log of x plus 3. Basically, that's what they're telling me. When are those things intersect? When are they the same? When are they equal? And so this will end up being the natural log of x plus 15 over x. That is 15. (15) is equal to the natural log of x plus 3. And here's where I can drop the natural logs. Multiply both sides by x. Oh my gosh, I got another x squared. X plus 15. Ohio gozaimasu. Thank you. Uh-oh. Somebody's in trouble. Somebody's in trouble. So I dropped the logs, multiplied both sides by x in one step. And so now I have x squared plus 2x minus 15 equals 0. Don't ever try to factor with a negative x squared. Don't do it. Move everything to the other side. The amount of mistakes I see on that is crazy. Plus 5 minus 3. X equals negative 5 or 3. Negative 5 is bad because negative 5 plus 3 is negative 2. I can stop right there and check it. 3, I'm okay. 3, I'm okay. Beautiful. Man, this is fun. Holy cow. Couple more. Woo! You can't say I didn't teach you enough today. H of x equals that. K of x equals that. In the xy plane, what are all the x coordinates? Oh, it just wants the x coordinates of the points of intersection of h and k. It's a good thing they want the x coordinates because that's all I'm finding. I'm not finding the y coordinates. So h is log base 3 2x minus 3 times x plus 4. I'm going to go ahead and do that as one step. All of that's h of x. And I want that to be equal to log base 3 8x plus 2. Luckily, you guys have a little bit more room than I do. Normally, I wouldn't show that as one step. Y'all okay? Can y'all follow that? Y'all okay? Where? Now I can drop the logs because I got a log on one side. A log of something is equal to log of something, so drop it. Go ahead and multiply 2x squared. 8, negative 3 is negative positive 5x, negative 12. 8x plus 2. Starting to get out of the pre-cal and going to algebra 2, and that's where it starts getting hard. You guys that take calculus next year, that's what you're going to find out. The calculus is easy. It's the pre-cal and the algebra 2 that makes it hard. Calculus is pretty easy. The calculus part of it. Algebra 2 and the pre-cal is brutal. All right, anyway, 2x squared minus 8, that's negative 3x. That's negative 14. Oh gosh, we got a stupid factor with a, oh my gosh, man. All that factoring that your algebra 2 teacher said you're going to have to do. 7 here and 2 here. Nope, 4 and 7. Yeah, 4 and 7. Negative, positive. Yep. X equals 7 halves or negative 2. I'm not negative 2. 7 halves. 7 minus 3. 7 halves. I'm good with 7 halves. You have to check. You have to check. You have to check. Just because you get a negative answer doesn't always make it not work. Be careful. Right? Sometimes the negative answer works and the positive answer does not. So don't just mark off the negative because you think it won't work. You got to check it. You got to check it. Woo! That one amped up there a little bit. Oh, these last 3. Okay. So these, they don't really involve logs. They just kind of involve exponentials. You got 2 to something is equal to 2 to something. That's kind of like log of something is equal to log of something. if 2 to something is equal to 2 to something, those somethings have to be equal. So you can drop the 2. Don't cancel them out. You can just kind of drop the 2. And the 5x minus the 1 has to be equal to 2x plus 7. They have to be. They have to be. And so this 2x will come over here and make 3x. That 1 will go over there and make 8. And then I'll divide it by 3. So x equals 8/3. You don't have to check these because you're not taking the log of anything. The only time you have to check is when you're taking the log of something. All right, so this next one, oh, that's as far up as I can go. I don't have 2 to something equals 2 to something or 8 to something equals 8 to something, but I can rewrite 8 as 2 to something. I can rewrite 8 as 2 to something. So let me do that. I'm going to write that as 2 cubed. But 8 is to the 3x minus 2. And now I have 2 to something's equal to 2 to something, so I can drop the 2's because the somethings have to be the same. So that would become 9x. You'll have more room to do this than I do. 9x minus 6x plus 5. I went ahead and distributed. Okay. Move that x over, that's 8x. Move that over, that's 11. 11 over 8. Am I okay? I'll miss one of these because I'll add when I should have subtracted or something. Uh, 9 to the 2x, 27x plus 2. X minus 2? X plus 2. All right. 9 to something equals 27 to the something is not the same basis. And I can't make 27 a 9. I can't make 9 a 27, but I can both make them 3's. So this is 3 squared to the 2x. Notice how I kind of keep things parentheses. 3 squared is 9. 9 is to the 2x. So 3 squared is to the 2x. 27 is 3 cubed to the x plus 2. Now I have 3 to something is equal to 3 to something, so I can kind of drop the 3's. The somethings have to be the same. And so you have 4x equals 3x plus 6. X equals 6. If you can make them the same bases, do it. If you can't make them the same bases, it becomes really hard. That's part of B. If you can't make them the same bases. But hopefully you can. Everybody okay? Good? I really should do that here, I guess. Where am I at? Good enough. 1/2 to the 5x plus 7. 4 to the x. 1/2. I already forgot. 5x plus 7. 4x? Huh? Oh. We're happy? Okay. Whew. I remembered that part, but I forgot. Yucky. This becomes 2 to the negative 1. And this becomes 2 squared. I think writing those with parentheses helps you. I think. So now you got 2 to something's 2 to something. Let's get the somethings the same. So this is negative 5x minus 7 is equal to 2x. Move that over there. That's 5 and 2. That's 7. 7 divided by -7, -1. Yay?